looking at the credits under the water category, site design for water, there are 2 prerequisites and 4 credits. And the first prerequisite is to manage precipitation, rainwater, on site, basically to address the rainfall that falls on a site and to not just convey it somewhere else. And how that is measured is part of the credit, and there are but that's a minimum threshold. And basically, in pretty much any place that has a building code, you can't just let 100% of the surface water that falls on a newly developed site run off. So it's pretty much, in most places, it's meeting local codes. So it's not a very high threshold, but there are some places that don't have that requirement or they don't enforce that requirement. So in order to get certified, you've got to show that you met that requirement. And then the first credit is to manage precipitation beyond that baseline. So basically to go beyond that minimum requirement and to slow, cool, cleanse, and infiltrate more rainwater than that minimum standard. And actually, within that credit, you can see there are 4 to 6 points. So 4, 5, or 6 points, depending upon what. And the way that it's measured is the percentage of a typical rainfall event. And actually, I can't remember off the top of my head. I've got the reference guide, but percentage of let's say a 2-year storm in wherever you are by retaining, I think it's 40, 60, or 80% of that storm event on site gets you those different point thresholds. So the idea is to avoid surface water runoff, because the experts that came together as part of this agreed that surface water runoff is the problem that stems from not addressing rainwater locally on site and is aggregated downstream. So that's the problem we're trying to address, and by requiring every site or encouraging every site to manage rainwater locally, then we're going to address that problem with surface water runoff, impacts to downstream hydrology and so on and so forth, flooding and so forth. So that's the basis behind both the prerequisite and the credit. And this is actually one of the site credit options that you can have under LEED, is to, it's not a prerequisite, but there is a credit associated with managing stormwater volume. There's also under LEED a credit for managing stormwater quality, and basically demonstrating that you remove up to, or a minimum of 80% total suspended solids from any water that does leave the site. And we talked about that. Actually, we had a water quality credit early on, and most evidence shows, most studies show that if you manage the rainwater and avoid surface water runoff and infiltrate using bioswales and rain gardens and green roofs, that you are really achieving that, removing most of the constituents of that water column. And so it was redundant to have that additional water quality credit. So that gives you a sense of some of the evolution of these. So those are the managing rainwater on site. And then the second prerequisite is water conservation. So reducing the amount of drinking water that we use to maintain landscapes. And there is a threshold for that, and it's set up. Now it aligns with LEED. It didn't in the first version that came out in 2009, but it now does. And basically, comparing to a typical sort of baseline for your geographic area, what would be the normal approach for landscape irrigation and using water in the landscape, and then showing and I believe it's a 50% reduction from that typical. That's all you need to do to meet the minimum standard. And here in Chicago, that's not a very high bar. It's, in fact, a lot lot of sites are developed without any irrigation at all, and certainly specifying, depending upon what it is, specifying landscapes that require less water is not too difficult. It is a big challenge in other more arid parts of the country, California, Southern California, and Arizona and New Mexico, where that's not standard practice. Standard practice is having lush green landscapes using exotic, a lot of exotic plants, and requiring a lot of water to maintain them. So as we developed these credits and got feedback from people all around the country, some were, yeah, make it more stringent. That's too low of a bar. Others were, no, that's unrealistic and impractical, and we're not going to participate if that's. So you can see the challenge of the balancing act to get to how can we be as aggressive as possible, but not exclude vast areas or types of projects. So this is where we landed. So reducing water use for landscape irrigation, and then there is a credit associated with further reduction in outdoor water use. And it's the same idea. The degree to which we get to no drinking water used in the landscape is how you get the 6 points on that credit. And there are 2 other credits in the water category. And one of them is that that any element of the site that is part of the water system, that it be designed and maintained as an amenity. In other words, we don't have any utilitarian stormwater detention pit or basin that is otherwise unattractive and not an amenity but a liability for a site, as is too often the case. And that's main point of this is that anything that is part of that rainwater management, because a lot of places, most places now require some level of stormwater management, and you have to detain. But if all you do is pipe your roof water and your parking lot water into a hole in the ground and then let it out as fast as the law allows, that is not going to be a very desirable or cherished or loved or sort of space that people would want to sustain over time. So designing any aspect of the water approach to a site as an amenity, which means that it can be a rain garden, but you just can't pipe 100% of your hot, dirty, polluted stormwater right into that basin and expect it to be an amenity. You've got to do some other things as part of it. And there are lots of descriptions of how to combine those strategies I just mentioned: permeable pavement, bioretention and bioswales and rain gardens, rainwater harvesting and reuse off of rooftops is a pretty easy thing to do. And you can have a lush green landscape in a more arid climate if you do that and not use any drinking water. It's a little more to it. There's something to do with, there's some operations and maintenance of that system and so forth, but it's a way to get at living within the means of that particular geographic area. So that's credit 3.5, and there's a range of thresholds a range of points depending upon the level to which that water amenity is accessible. If it's visible but you're still not allowed to go in there because it might flood or there's a water quality issue, then you're not getting at the full intent of that credit. If it's visible, accessible, touchable water, basically, now we can connect with that water, that rainwater, as a resource and not a waste product. That gets at the full intent. One of the examples I like to use is some of you may be familiar with Prairie Crossing, and a community up in Grays Lake that was an early version of an eco-village, and there's a lot that has been done there along the lines of what we're talking about here. One of the things was to have the stormwater management be very much aligned with these philosophies, and it predated this by a number of years, but that idea, and basically the overflow storage for surplus rainwater, surplus stormwater, is an excavated lake that was excavated into the farm fields, and by doing all this other stuff, by basically having all the runoff from streets and rooftops go through naturalized landscape, bioswales, and so forth, and enter that lake only as clean, cool base flow, the water quality is of such integrity that it supports very conservative native aquatic plant species and animal species, and it's actually been certified as a repository for threatened and endangered fish species. And it has a public beach, and you can swim in it. So imagine that of a typical detention basin, you know, but it's imminently feasible, and that's so. And this was actually the credit that I did more with as part of this. So I'm a little bit biased and passionate about that one, but it really is just a huge opportunity, like I said, to not squander any part of the site or water and make it a valuable resource. And that sort of relates a little bit to the last one, which is restoring aquatic ecosystems. So basically, any place where, and as probably most of you know, most of the aquatic ecosystems, especially wetlands, throughout much of the country have been degraded, displaced, or completely obliterated mostly through agricultural operations, but in some ways development, and depending upon where you are. And so there's a credit or series of points associated with restoring, bringing back those characteristics and qualities to sites. And in some cases where it depends on the site, if it's been completely altered, then you're really creating, in some ways, an artificial wetland. But if it is done in a way that is in harmony with natural processes, then you can get a lot of those same ecosystem service benefits, not nearly as much as a remnant wetland, but you can provide habitat for birds and beneficial insects. You can certainly provide a visual amenity. You can have it be part of an overall water system and have other benefits. So those are the credits associated with water.